Hello, my name is Lily Wang, and I'm pleased to be presenting this paper today, co-authored by Laura Brill, Jayden Nord, and James Bovaird. Here at the University of Nebraska, we recently completed a grant that was sponsored by the U.S. Environmental Protection Agency entitled Evidence-Based Interactions Between Indoor Environmental Factors and Their Effects on K-12 Student Achievement. And our primary research question was, how do indoor environmental conditions in K-12 buildings impact students? So we have completed measurements of 220 classrooms in 5 local school districts here. They include 3rd, 5th, 8th, and 11th grade classrooms. And in each of those classrooms, we made both measurements during the occupied school day, as well as measurements in unoccupied conditions, typically after school dismissal. The occupied measurements were typically deployed before school started one day and then left in the classrooms to log data over the next 36 hours. And we did this, so we had 2 school days during one visit. And then we visited every classroom 3 times so that we could get some seasonal variations, particularly in the thermal comfort and indoor air quality data. So in total, we would have 6 days of occupied measurements for every classroom. The next slide shows a picture of the equipment that went into the kits that were left into the classrooms during the occupied measurements. There was a kit that was placed near the teacher's desk, which had many different pieces of equipment, including a sound level meter. Then we also had another sound level meter that we would hang elsewhere in the room, farther away from the teacher's. In terms of the unoccupied measurements, we gathered basic information about the room. And then there were a number of different metrics that we gathered that weren't expected to be impacted by an occupied state. And so in terms of acoustics, it's the impulse responses that we would measure after school. And from that, we could extrapolate a number of room acoustic metrics. So let me focus on the acoustic measurements, since this is a talk at an Acoustical Society of America meeting. On the unoccupied side, from the impulse responses, we could extrapolate reverberation times. Typically, we got T20s, and we would look at them in different frequency ranges. So we had low frequency average, and mid frequency average, and a high frequency average. We also could look at clarity indices. And during those unoccupied times, we often would also try to gather a 1-minute unoccupied reading of the A-weighted sound level, equivalent sound level, to try to assess what the general background noise might be in that classroom without students in it. In the occupied side, remember, we left meters in the schools, and we logged over 6 school days. Every 10 seconds, an A-weighted equivalent sound level. And we would also get octave band data from 32 hertz to 16 kilohertz. So with that data, we used a k-means clustering algorithm, which then could cluster based on all this input data into 2 sets that were similar, but just to themselves, but distinct from each other. And when we looked at the spectral components of those 2 clusters, we noted that one cluster had high spectral components in the speech frequency ranges, and the other one didn't. And so we have labeled them as one cluster being where there's active speech happening in the room, and the other one where there's not speech going on in the room. Here's a plot of an example classroom. So you can see the class from 9 to 3, one day of this particular room measured in the fall. And the data points marked in black are those that have been clustered as speech data points, and the ones in red have been clustered as non-speech. So having this data for every classroom and every occupied day allowed us to look at how often are students in this classroom exposed to speech versus non-speech. And we looked at that over grade. And so here's a plot where you can see the 4 grades we studied. And the 3rd grade classrooms did experience more percentage of speech over a school day than 11th grade classroom, 1.2% of the day, with standard deviation lines showed, whereas the 11th grade classrooms experienced at 54.9%. So we did gather demographics And also I wanted to share a little bit about what the outcome variables were that we looked at. In terms of demographics, we got classroom aggregated data on the percent of students in that classroom who receive free or reduced lunch. We also got a percent of students in that classroom who are gifted learners and a percent in the classroom that identified as special education learners. On the outcome variable side, we had percentile scores from math achievement scores and reading achievement scores that were given to the students, typically at the end of the school year in April. And we received those also as a classroom aggregate. So I would like to present the results of a model I'm going to call model number 1. Many of the metrics that we ended up calculating were correlated with each other, and so we had to do some confirmatory analysis to decide which model we would move forward with. And this was one that we've been following up on and have presented on the previous ASA meetings. There is one metric that describes the non-speech experience of the students, and one that describes the speech experience, the experience of speech by the students, and then one that describes room characteristics, which in this case was the mid-frequency average of the reverberation time, T20. So what we would do is, remember we have 6 occupied school days of data. We would look just at one day. We thought that was a good unit to be looking at. So what was here, the level L90, which is the level exceeded 90% of that day. And then we would look at it for each of the 6 days for a classroom and arithmetically average those 6 to use that as the value that would represent this classroom for that category. And similarly for speech, we looked at the A-weighted equivalent sound level of the speech cluster over one day, saw what that was over all the 6 school days, and arithmetically averaged those daily values. So these were our 3 metrics, and we controlled for the demographics I've already presented. We also explored interactions between the demographics and the metrics. The results show that there is a statistically significant effect of one of our acoustic variables on math achievement. We do also see it with the demographics at a p-value of less than 0.01. And if I focus on the acoustic variables, it is the speech one in this model that shows that higher levels of speech correlate to lower math achievement scores. None of the other main effects of the acoustic variables were significant in this one, and there was no effects found on reading achievement. So I'm only showing the table for math achievement. So this is interesting to us, and you might be saying, well, how come the speech levels correlated, but the non-speech levels here did not, the L90N? And our co-authors, who are the experimental psychologists, would explain that it's because there is a correlation between the fact that when there's higher speech levels, there are also higher non-speech levels. And so in this model, most of the variance is being accounted by this speech metric, and anything that would have been accounted by L90N is already absorbed through the speech metric. On the next screen, I want to show a little bit more about this interesting interaction where the effect of that speech level in the classroom interacted with the degree to which there were percent free and reduced lunch students. So I'll read the statement first, that what we found is as percent free and reduced lunch recipients in a classroom increases, we found a higher level of speech has a greater negative relationship with math achievement. So this red line is a median. You have speech level on this x-axis and percentile rank on the math achievement scores on the y-axis. And so for out of all our sample, if you took the mean value of what percent free and reduced lunch was, that if a classroom had that mean value in general, there is a negative effect as speech increases, the math achievement score went down. But if the percent free and reduced lunch in the classroom is lower, if that percentage is lower, that effect is not as strong. Whereas if there was a greater percentage of free and reduced lunch students in the classroom, this is drawn as +1 standard deviation from the mean to -1 standard deviation from mean, then that effect is even stronger. So we thought that that was an interesting relationship to show. So We received some feedback as we've been presenting this data over the past few months, year to 1 year. And we also have been thinking about the model ourselves and how it might be useful to those in the classroom acoustics design community. So our classroom acoustics standard has a sort of it wants us to know what the noise, the ambient noise that students are learning in, and then to have an appreciable signal to noise ratio above that for appropriate speech intelligibility. So when we looked at this data and actually taking this example that I showed earlier again, L90N, which would be the level exceeded by the noise cluster 90% of the time, is pretty much a low end. And if you think about it, the students are experiencing this sound level. So we began to think that maybe it would be better to actually look at the A-weighted equivalent average of the noise of the non-speech cluster, because that would give, particularly in this particular room where there's a cycling mechanical building system, there would be louder times and quieter times, and that LAQN may be a better representative of what is being experienced in the classroom average. So we tried a second model where we took the LAEQ instead of the L90. Again, it's of that one day, and we have 6 days, so we arithmetically average those, and we use that as a metric for non-speech. Then we thought maybe to help with matching to the ANSI standard, we could look at something like a signal to noise ratio that over that day, what was the LAQ of the speech cluster? And we'll subtract the LAQ of the non-speech cluster. So we have some delta for one day, and then we get it for each of the other days, and we arithmetically average that difference. So this is not exactly the same values in, so this is an average across the 6 days, whereas this one is looking at every specific day and the delta to the particular speech that day. Still using T20 mid-frequency average, and we're still controlling for classroom demographics and looking at interactions. And the results are similar to what we saw with model number 1. The effects on math achievement, as we'd expect, very statistically significant effects of all of our demographic variables at a level of P less than 0.01. And in terms of our acoustic variables now, what is shown is that it is the non-speech levels that are accounting for that are correlating to lower math achievement scores in this model at a very statistically significant level, P less than 0.01. And as before, there's no other main effects. Actually, in this case, there were no interactions with the demographic variables, and there was no effects on reading achievement. There is still a significant correlation between these two, that as the noise level, the non-speech levels increased, typically this difference between the speech cluster and the non-speech cluster shrank a bit, but they are still correlated. So in summary, our project results show that higher average daily speech levels over the school day correlate to lower math achievement scores. And an alternate model indicates that it's also related to higher average daily non-speech levels. We didn't find any relationships with reading achievement, though, unlike previous studies like Ronci and Wang. I would like to emphasize that our study shows primarily correlations, not causations. We do have additional data on 55 classrooms, some of which we did make changes to look for causation. And we're still working on that and planning to use others of that sample to cross-validate the current statistical model. We do encourage that future studies should work with school districts, although it can be difficult, to test such changes so that we can get at causation and not just correlations. We'd also suggest that individual student data be analyzed in the future. In this study, we only did classroom aggregated data. So thank you very much. And if you'd like more information, please visit our website.